Welcome to Excel magic trick number 1366. Hey, if you want to download all of these files so you can follow along, click on the link below the video. Hey, this is an epic video about Power BI Desktop. We are going to see the whole process. We're going to import data from multiple sources, create multiple relationships, create DAX formulas, both calculated columns and measures, and then create some visualizations. Now, these are the files we're going to start with, including our Access database, which already has a table and existing relationships we want to use. We will import them all into Power BI Desktop, get all the tables together, create our relationships between tables so we can pull criteria from our lookup tables or dimension tables and filter the fact table. And we will create DAX calculated columns and DAX measures. Now, we have a bunch of topics in this video, importing a number of different file types, creating relationships, learning how to sort so months appear correctly in our reports, creating DAX columns and DAX measures, including a DAX column that will help us simulate approximate match lookup, creating a frequency table, product analysis visualization, format those visualizations, and then add new data to test if our whole reporting system updates. Now, the very first thing we're going to do is we're going to look down to the taskbar. That little icon is the icon we clicked to open up Power BI Desktop. Now, if you don't have it, you can simply search Google and download it. It's easy to download, and it is a quick install. And it has all sorts of features. And if you've used Power Query or Power Pivot, you already know how to use half or more of the features in Power BI Desktop. Now, I'm going to go ahead and click this icon to open. Now, here we are in our blank canvas. Right here, this is where we go to look at tables. This is where we go to look at relationships. Back in our blank canvas, if we want to import data, we use this option, and it's almost exactly like Power Query over in Excel. Here are some various visualizations. Our tables and fields will be listed over here. If we want to create DAX formulas, measures, and columns, we come over to the Modeling tab. Now, back over on Home, before we do anything else, let's save this. Untitled is not a good name. Either Control-S or F12. They both work over here in Power BI Desktop. I'm going to give this a good name. 1366 Power BI Report Finished, and save it. I'm going to click a good location and click Save. Now, let's go look at our files over here. These are the text files that have our transactional sales data. If I open one of them up, we have columns like date, product ID, units, revenue discount, net cost equivalent for cost of goods sold. I'm going to close that. Our Access database, if we open this up, here is our product table, product ID, product, suggested retail, standard cost, foreign keys for company data and category data. Those keys link to these other tables over here. And there is a web address for pictures for each one of our products. If I close this, go over and look at D category, we have categories for our products, boomerangs, kites, and toys. We need those categories so we can filter our reports to see just the categories we want. And then over in supplier, really the only column we're going to need is the company name, because we want to be able to filter our reports by company name. If I go over to relationships, there's already one-to-many relationship. This is the primary key. ID company. Over here, we have ID company, but there are many duplicates over here because we have many products from each company. Similarly, many products can be categorized as boomerangs, toys, or kites. This is a one-to-many. When we import this into Power BI Desktop, those relationships will be imported also. Now, let's go over to Power BI Desktop. The first thing I'm going to import is the product data and those two related tables. So I'm going up to Get Data, down to More. Over here, I see Access Database. That's what I have. I'm going to click Connect. select. Now I have found the file I want to import, so I'm going to double click. Now it lists all the tables. We want all of them. I could click this, but I'm simply going to click on the D products. And look at this down here. This is a relatively new button. I can select related tables. If I click this, the other ones are selected. It searched through the Access database and found D product was related to the two others. Now I could click Edit, but I'm going to send these straight to Power BI Desktop by clicking Load. We can see it's loading the three tables. Now if I go over to Table View, there's three tables listed over here: Category, Product, and Supplier. If I go over to Relationship View, look at that. It imported the relationships. Now, one thing it did do here, those are one-to-many relationships over in Access. These are our lookup tables or dimension tables. One ID for company. Each record is a single unique company. And over here, of course, we can have many companies. Down here, we have the D category with what's called our primary key or unique identifier. And we have a unique list of categories. That means this is the one side to the many side. We can have many products over here that are categorized as boomerang, toy, or kite. Now notice there's a one-to-many relationship, but look at that. That's a bi-directional arrow. Now we can change this. It wouldn't hurt us for our reports, but we can change this to a one-to-many with an arrow only going this direction. That means the filter, when we filter in a slicer or a chart to show only boomerangs, the filter will flow this way to the many side. But right now with the double arrow, if I filter something here, it will filter in the other direction also. So I'm going to change this to a one-directional filter. I'm going to double click. And over here in the cross filter, instead of both, I'm going to say single. Click OK. Up here, double click. And under cross filter direction, I'm going to say single. All right, so we have our three tables from Access. Now we need to go and get the text data from two different text files and consolidate it or append it, one table on top of the other, into a single proper data set. So we're going to use Get Data, More. And this time we're going to use the folder option. We want to get all of the text files in a particular folder. I'm going to click Connect. We can click Browse, and there's our folder. What we're telling this query is please import all of the files in that folder. Now remember, in that folder are many different file types. We'll have to filter out everything except for the text files. Click OK. Click OK. And we want to click Edit. Now we can see here's a list of our file names. There's a list of the extensions. We want only the text files. Now the first thing I'm going to do is I'm going to come over and name this. These text files are going to turn out to be our fSales table. So I'm going to name the query here fSales and enter. That name will also be the name of the table that's imported into Power BI Desktop. Now, the first thing we want to do is I want to filter out everything that's not text. Now, just in case we get someone who named their file with capital TXT, I want to transform this column here, right-click extension, down to transform and lowercase. Now, why do we need to do that? If we were over in Excel, there's no difference between capital T and lowercase t. But here in the query editor and in Power Query over in Excel, it's all case sensitive. So now if it comes in capital TXT, that transform, and we can see the step over here will automatically make them all lowercase. Now we want to filter. I'm going to use text filters. And please only import files that equal .txt. And click OK. Now we filter those out. Now we want to come to content. We don't need any of these other columns. If I click that double downward pointing arrow, it's going to do something new. If you've used this button over in Excel, it doesn't ask you what delimiter you're using. But now it does over here in the query editor in Power BI Desktop. Not only that, but it's actually going to add some queries, including it's going to ask us when I click this button right here, it's going to ask us, do you want to use the first file as a sample? Then the editor will write the code, build a function, and use that function on all the remaining files. So let's see this. I'm going to click double downward pointing arrow. I can see right here that's not what I want. It doesn't know the right delimiter. So I'm going to click the drop down, and this is tab delimited. That means there's a tab between each field for each record. The query will use the fact that we said tab here and build some M code to help extract the rest of the files. I'm going to click OK. Click Apply. Now, over here in the table view, you can see a preview of the table. But I actually want to go look at the query and what it did. I'm going to click Edit, Query, Edit Queries. And this is what it did. It added a bunch of steps over here. But look at this. It actually created some new queries. Now, I'm going to look at a few of these just for interest. That's the step where it says, hey, do you want to use that first file as an example? Then it wrote this code. If you click on that step, go to View, Advanced Editor. There's the csv.document to extract from a text file. It promoted headers and changed type. That's the code for that first file. When I click Done, it then built a function. And we can see that little f of x. We can even go click Advanced Editor to look at the code. This is warning you. If you ever want to change the code, don't change it in the f of x step. Change it in the previous step, because anything we change here will show up in the function step. I'm going to click OK. And there's the code that was created in the previous step. But look at this. It added. And this is what it does when it creates a function. In parentheses is the name of the variable. That variable will be the various different text files that it's going to look at and try to extract. Equal sign, greater than, that points down to the code that the function will use. You could see right here, csv.document. That's the variable name from up here. So if there were many text files, it would put each one of those text files here, extract it, and then go on to the next. This is our function. I'm going to click Done. If I click down on the final query, fSales, there it is. Now, I'm actually going to change and add a step here. We can see that it actually didn't change the data types. So I'm going to click the little icon to the left in the date field to expose different data types. I'm going to define this as a date data type. Come over to this field, click the icon. I'm going to define it as text. Units, well, that's going to be data type whole number. Then click on Revenue, hold Shift, click on Net Cost Equivalent, right click, change type, and I'm going to change this to decimal number. Now, it's added a step here to our query, just like it would do in Power Query over in Excel. Now, over here, it doesn't say close and load like it does in Power Query. Here it says close and apply. And now we can see our sales table with date, product ID, units, revenue discount, and net cost equivalent. Now, let's go look at the relationship mode and look what it did. It tried to be polite. And I'm going to move this around. And look at that. It automatically sensed that there was an ID-product and an ID-product over there and created a one-to-many relationship, including the directional arrow that we wanted. And that makes sense. If we're importing a lot of data, hopefully we're consistent with our names. If they're not, you can build the relationship. Actually, you can build a relationship by simply clicking and dragging one field on top of the other. Now, we still have two other tables that we need. I'm going to Control S over here in Power BI Desktop and go over to Excel. Now, I want to click on the sheet D Calendar. And we need to create a lookup table for dates. Now, this is called a calendar table or a date table. If we were in Power Pivot, there's a button to create an automatic date table. But I don't know where that button is in Power BI Desktop. No problem. We're going to create the date table over here. We need the first column with a unique list of all of the dates with none missing. And then for whatever category we want to use in slicers and charts, year, month, month name, and so on, we have to create extra columns. Now let's learn some great tricks in Excel. First, we do have to know the min and max date. I know the transaction set starts with 1/1/2016. Now I'm going to Control Enter, and I need to copy this all the way down. Our data set ends at 17, but I'm anticipating getting data for the next 2 years. So I need this list of dates to go all the way down to 12/31/2019. Here's a great trick. That little thing right in the lower right-hand corner is called a fill handle. When you take your selection cursor and you move it on top, it turns to a crosshair or angry rabbit. You want to right-click, drag down, drag back, and let go of the right click, and up pops a secret menu. Now let me do that again, because this is a great trick for any incrementing of numbers. Right-click the fill handle with your angry rabbit. Drag down, drag back, let go, and there it is. We want to point to series. Now we need to fill the dates down in a column, so I have to make sure and say the series is in column. Increment by 1 day, that could be anything. And the stop value, it doesn't have to be an integer. It can just be 12/31/2019. When I click OK, boom. That is amazing. Control down arrow to check. Perfect. Control home. Now we need to, with functions, create from a serial number date the year, month, and month name. Well, the function in Excel is the same as if we were actually manually creating this over in either Power Pivot or Power BI Desktop. It's the year function. It looks at the date, Control Enter, and it tells you just the year. Month number, this function is the same in DAX and in Excel. Month, Control Enter, double click and send it down. And then month name. Now over here in Excel, we use the text function. If you're over in DAX, there's no such thing as text. It's called format. But it works exactly the same way. You give it the date, comma, and then you have to use custom number formatting for, in our case, month. M is for month, D is for day, Y would be for year. Now you have to put it in double quotes. If I put a single M, it actually would give me the same one I see here, but as text. 2 M's would give me a leading 0. 3 M's gives me a 3-letter abbreviations. And 4 M's gives me the entire month name. I just want abbreviation in double quotes, MMM, close parentheses. Over here in Excel, it's text. Over in DAX, it's format. Control Enter, double click, and send it down. Now, before I bring this into Power BI Desktop, I need to convert it to a table so it's fully dynamic. With a single cell in the table, insert table, or use the keyboard Control-T. My table has headers, click OK. We definitely want to go to Design, Properties, and the table name is going to be D Calendar, and Enter. Now, I don't like to have the same name on a sheet as table when I'm doing lots of importing, so I'm going to come down and rename this sheet. Click at the end and type SH for sheet. All right, so we'll import this in just a second. But we have one other table we need to create. Not only that, but this table usually is created later in the data model building process. Once I know the max and min values, for our analysis, we're using gross profit. Now, I already did it, so I know that there's a few small values below 0. So I put minus 250 as the lower limit for the first category because we want to count transactions in terms of gross profit. The next lower limit will be 0, then 250, 500, and so on. Now, I've already converted this to an Excel table, but watch this. I'm going to use something similar to that series trick. I've established a pattern here. So now I can point to the fill handle with my angry rabbit, click and drag. Notice the screen tip is telling me what number. And I know 3,000 is the max gross profit for a single transaction. But watch what happens when I let go. The table is totally expanded. Now, we're actually going to use this to build a frequency distribution. This is also how you'd create a histogram. But I like to have explicit categories. Right here, I want an explicit category that says lower limit is 250, upper limit is 0. So watch this. Equal sign, I'm going to, using table formula nomenclature, I click there, and it's the @ symbol. By the way, this is very different than what's called row context in a calculated column in DAX. Over in DAX, all we have to do is put the field name in square brackets, and it knows to get the value in the current row. But over here in an Excel table, we have to use that @ symbol. All right, I want to use the join symbol ampersand, and then in double quotes, I want to say the gross profit has to be greater than or equal to gross profit space less than space end double quote ampersand, and then the next lower limit. Now, what this is going to do if I hit enter is it actually gives us a category where the variable is in the middle. Our variable gross profit has to be greater than or equal to the lower limit and less than the upper limit. Sometimes you see this notation in algebra. You don't see a lot of it in data analysis or business intelligence charts, but I like it. It's very explicit. It tells me exactly what this category is each time. Most of the time, you just see this, and that would be fine also. Now, the last one doesn't work, so I'm going to very carefully highlight everything after GP and type N double quote, because that last category is simply everything greater than or equal to. Now, we're actually going to do something really cool with this table over in Power BI Desktop. We'll actually simulate approximate match lookup. Now, I need to save, and then I need to import both of these tables. Now, I'm going to close this file. And over here in Power BI Desktop, I'm going to say get data from an Excel file. I'm pointing to the correct location. That is the file. I'm going to click Open. Now, I made a mistake, but now we can see why I use the SH. Naming conventions are so important. I don't like this. That's too ambiguous. So I'm actually going to close this and go back over to Excel, open the file, and down here I'm going to call this SH and enter. So now our naming convention, the sheets get sheets, the table just have the table name. Control S, close. Back over here in Power BI Desktop, get data, Excel, double click. And that's much cleaner. Now, I just need these two tables. So I'm going to select both of them and then click Edit. It added 2 extra tables here. I'm looking at gross profit category. This number as an integer is perfect. This one as text is fine. I click on decalendar. Date, number, text, those are fine. So now let's close and apply. Both of those tables will be added. Here's the decalendar. I'm actually going to move these around a lot. All right, so now I've moved them around, and let's create a relationship between the two dates. So I click on the date. I drag it over to date in fSales and drop. And there it is. Many, because we have many transactions on a given day, to one date over here. And there is the arrow from our lookup table or our dimension table to our fact table. Now, we cannot create a relationship, and there's a few ways to deal with categories like this. I'm actually going to create a calculated column over here that will list all of the lower limits, and then I'm going to create a relationship. So we're done with importing our tables. I'm going to Control S. Now, our next step is to create our DAX calculated columns and measures. I'm going to go over to our table area. You can also create DAX measures over in our report area. And we're going to select fSales, and our first DAX formula will be a calculated column for net revenue. And then we'll create our first measure for total net revenue. Now, notice all we have in this table are units and the revenue discount. We do not have the price as a column. If we go look at our products table, we could see if we had something like VLOOKUP, we could look up our product ID and retrieve the price. Now, notice something. This is an exact match. I'm going to go back over to fSales. So we do have product ID. The function that we use rather than VLOOKUP, which we'd use over in Excel, is called related. But related only works when there's an exact match. But no problem. That's what we have here. We want to go to modeling, and there's measure and column. I'm going to click column. Now, in both cases, measures and columns over here in Power BI Desktop, it immediately highlights up in the formula bar. You can't even click over here. If you click over here, it goes away. That's different than over in Power Pivot. It has it highlighted. I'm going to type net revenue and then space, equal sign, and a space. Now, over in Power Pivot DAX calculated column, we use an equal sign, same as over here in Power BI Desktop. Now, I'm going to see if I can look up the price. So I'm going to type REL, and there it is, related DAX function, returns a related value from another table. Sounds like VLOOKUP exact match. Now, why is it called related instead of VLOOKUP? Because guess what? There's already a relationship between this fact table and the product table based on the primary key, the product ID. Now, all we have to tell related is which column we want to go and retrieve. Now, we're going to type out the table name, D product. Notice our drop-down shows us all of the either tables or tables, and then in square brackets our field name. I'm going to arrow down until I get suggested retail price. And that's it. That's all you have to do to look up something with exact match. Close parentheses and enter. And look at that. It looks up the price. Now, how did related know to do that? Well, let's go look at our relationship. Here is the relationship between fSales table that has the ID product, and the relationship goes to the primary key ID product over here. Every time in the fSales table it sees a particular ID for product, it goes over to this table, and it knows which row because this is a primary key. But guess what? It also knows to get the suggested retail price because that's the column we put in related. So if I go back over here, for every single row, it sees through row context, it sees that particular ID and goes over and gets the price. Now, notice we saw over in Excel when we had a column in a table, it had that @ symbol. But this formula, D product square bracket suggested retail price, is the same formula all the way down. It just knows through row context. Down here it says EK49, so it knows to go over to the D product table through the relationship and get the suggested retail price. Now, that's not what we want. We need to take the price times the number of units times 1 minus the revenue discount. So I'm going to continue the formula up here, times, and now I'm going to type the name of the table, FS, to get to the fSales. We see the table, and then the table in all of its fields. I'm going to down arrow to get units and tab. Then times, open parentheses, 1 minus, and I need the revenue discount, so FS, and arrow down to revenue discount. Now, the discount is just the amount of the discount. We take 1 minus because we want the net amount. Close parentheses. If I hit enter, I may not see any extraneous decimals here, and I might be able to scroll down and see some at some point. There are some down there. And since each amount is a transaction in money, we need to round. So I'm going to come before related and use the round function. Now, the round function expects a number or a formula, and we come to the end, and we're going to type comma, and the number of digits is 2 because we're rounding to the penny. Close parentheses and enter. Now, we don't need to add any formatting because we're not going to use this particular field in any of our visualizations, at least not directly. If we look over here under fSales, there it is, net revenue. And that's the icon, that little sigma. That sigma means that is a number. That little table type icon with a sigma means calculated column. Now I want to create a measure, and I'm actually going to show you how to create total revenue. Now, total revenue is for us going to be an item under fSales. We'll be able to drag and drop it it will give us a total overall amount for all the revenue for all 200,000 plus records if we dragged it by itself. But anytime we drag it and there are conditions, criteria, or filters, meaning like product name or month, that net revenue will respect the filter and give us the amount just for that particular month or that particular product. Now let's go up and add new measure. I see up here, I'm going to type total revenue space equal sign space, and then I'm going to type SUM open parentheses. Now I'm going to stop here just for a moment because that's different than Power Pivot DAX measure. Over there, we use a colon and then an equal sign before the function and after the measure name. Now, we already calculated net revenue over here. So when I type fSales, there it is right there. It's showing up. So down arrow and tab, close parentheses, and enter. Now, we see if we look over here in our field list, down here it says total revenue, and that's the icon for measure. Like a little calculator. Why did they use a calculator? I thought calculators went away when Excel was invented 30 years ago. No, that's the icon they use. Now, this is something that we're going to directly drag into visualizations or tables or reports. So I want to format it. Now, I'm going to click back up here, and I want to format it using English United States. For this particular total revenue, I want to say 0 decimals. And that formatting is universal. It'll show up wherever we drop the measure total revenue. If we ever need to change that formatting, we change it here. And everywhere we use that measure, that number formatting will change also. I'm going to hit Enter. And if we look down here, we have our DAX calculated column and our DAX measure. Now notice that measure is dependent on that calculated column. Now sometimes we want to create a measure like total revenue without a calculated column. I'm going to show you that method here. We're actually going to create a duplicate total revenue measure. Now no sum of the calculated column. But let's create a new measure. And I'm going to call this total revenue sum x, because that's going to be the name of the function we're going to use inside our measure to simulate a calculated column. Space equal sign space. So you ready? We type sum x. Now sum x is one of a number of iterative functions. If you see an x, like count x, rank x, average x, standard deviation x, they all can simulate in the expression argument right here a calculated column. Now we'll talk in a moment about why you might want to do this, but let's see that we can get the same result. The first thing is, since that sum x is going to take whatever formula we put here, which by the way is going to be exactly the same as the formula we had in our calculated column, but sum x needs to know which table to iterate over, meaning it's going to take the formula right here and go through the table, but not as a calculated column, as a measure, and calculate for every single row the values. And then because we used sum, it'll add them. So you ready? The table is fSales. And this argument will only accept a table or a function that delivers a table. Then I'm going to type comma. And guess what? The expression is the same formula, round. And then inside number, we did related to look up the price times units times 1 minus the revenue discount. So related, tab. And we need to go over, because remember, sum x is making sure that related goes down the entire fSales. And since there's a relationship, we just have to say D product. And we're trying to get suggested retail price. Now I'm going to close parentheses times fSales and all the way down to units tab times in parentheses 1 minus fSales and down to get our revenue discount. Close parentheses. That's the entire number argument. Now I type comma 2 for number of digits, close parentheses. Now that whole thing right there, you literally could have copied it straight from the calculated column and pasted it here. Now I'm going to close parentheses on sum x, and I'm going to add the same formatting. English United States, 0 decimals. And there we go. Now we have two total revenues. Now let's go over to report view. And I'm going to drag both of these, one out here, whoop, and we'll get the total. It defaulted to a column chart. I'm going to come over and click card as our visualization. And then I'm going to drag the second one and click card. We get exactly the same amount. If I click in the white and add a slicer, I'm going to go to product. And because there's a relationship, when I select Carlota, it shows me exactly the revenue for Carlota. Aspen, there's the revenue for Aspen. Now, I want to go look behind the scenes, and we can't really look behind the scenes, but let's go over to the relationship windows. And what just happened to get the $2 million for Aspen was I had product from the product table on the slicer, and when I selected only Aspen, that criteria flowed from the one side over to here. It's in essence a filter because it filtered that huge $250,000 record table down to just Aspen, and then the formula's calculated on just the Aspen amounts. That's one reason that DAX formulas and the columnar database in the data model can calculate on big data so efficiently. Now let's go back to the report view. We don't need these. This was just for illustration. I'm going to delete these. And we want to go back to our table view and talk about the difference between, I'm selecting the revenue for SumX. That's the measure where we calculated total net revenue with just a measure, no calculated column. And then the second option was we actually created that same formula that was inside of SumX, but it iterated over the whole row, and those values are stored in the in-memory columnar database. And then we did total revenue, which was our measure to add up this calculated column. Now, when do you use one or the other? The rule of thumb is if you have really big data, and we're talking more than 10 million rows, the rule of thumb is most measures will calculate more quickly if you create them like this, not using a helper column. Now, that's not always the case. You have to time and measure to see which one is best. And in large part, it has to do with the fact that when you create a calculated column, these values are stored in the data model database. Now, behind the scenes, there's what's called a columnar database that stores each column in the table individually, only storing the unique values. That means if you have a calculated column that doesn't have very many unique values, it's not going to take up a lot of RAM memory. But again, the rule of thumb is for big data, in general, the measures alone will work more quickly. Now, the greatest DAX masters in the world are Marco Russo and Alberto Ferrari, and they wrote a bunch of books. And in their definitive guide to DAX, they say it plainly. Hey, if you don't have a big data set, you can use either method you want. You can use simply calculated column and then a sum measure, or if you prefer, an all-in-one measure simulating the calculated column. Either one is fine. All right, there's another reason that we might want to use a helper column, and that's when we want to create conditions or criteria to add to a filter or a slicer. For example, in our date table, when we looked over here, there was the original date, but all of these were calculated columns. Here it's just data because we imported it. But this is an example of when these extra columns, year, month, month thing, these are things that we drag into the axis on a chart or into a slicer as criteria. In those cases, you have to create a calculated column. Now, back to our fSales, we're actually going to calculate cost of goods sold and gross profits as calculated columns and then add them up using the sum function, because in general, those are going to be easier. And we have a small data set, so it doesn't really matter. And then we're going to create an extra column that creates sales categories, either wholesale or retail for each one of our transactions. That's an example when you have to use a calculated column, because we want to use those conditions in a slicer. All right, let's create a calculated column for cost of goods sold. And that will involve taking units times the net cost equivalent. This isn't the discount. This is the net cost equivalent times, and we'll have to look up over in the product table our standard cost. All right, so we're going to select fSales because that's where we want to create our calculated column. Click New Column, and I'm going to type COGS for cost of goods sold, space equal space. And it's going to be basically the same formula we did for net revenue. We're going to want to round because this is money and we have to round to the penny. We definitely need in the number argument to look up standard cost. So what do we use? Related. And all we have to do is put the column we want to go retrieve values from. So DP, and I'm going to down arrow to standard cost. Because we have a relationship between the product and the fact sales, every record, because there is product ID, will know to go and get the right standard cost. Close parentheses. Now that's the cost. We need to multiply it by our units from our fSales. So we go and get that. Tab, times, and FS, and then down arrow to net cost equivalent, and tab. That's our calculation. We need to remember to round, so comma 2 to round to the penny, close parentheses, and enter. There's our cost of goods sold. Now we can calculate a third calculated column. Net revenue minus cost of goods sold will give us gross profit. New column. Up here, I'm going to type gross profit space equal sign space. And I don't need to round because the two values I'm subtracting are already rounded. fSales, and I'm going to get that calculated column, net revenue. That's this column right here. Tab, minus fSales, and I need to get the cost of goods sold. Tab, and that's that column right there. Now notice, there's that formula. This is going to be copied down the whole column. And through row context, the table and field name will know to go and get the right net revenue and cost of goods sold for each row. By the way, we're talking about row context. And I'm going to hit Enter here, and it knew to calculate through row context. I should have used the term filter context. When we were looking back over on relationships page, remember we selected Aspen, and that filtered through to make this table smaller. But remember, it was the total revenue. That's an actual calculation, a measure that then understood that this table was filtered. That's called filtered context. That means our measures understand the criteria dragged into charts or slicers through something called filter context. That means we select it here. The filter flows this way, makes the table smaller, and our measure makes a calculation on that smaller table. Filter context. All right, let's go back over here. We just calculated gross profit using row context. Now we have a fourth column that we're going to create. And this is a column we're actually going to drag and drop into slicers and filters. And our rule is this. If units are less than 15 or the revenue discount is less than 20%, then the sale is categorized as retail. Otherwise, it's wholesale. So I'm going to go up and create a new column. There it is. We're going to call this retail wholesale space equal sign space. And guess what? We get to use the if function. Now, the if function works the same as over in Excel. The arguments are named a little bit differently, but it works the same. Now, our logical test is an OR logical test. We have two tests, and if either one comes out true, then we need to say retail. So we're using the OR function for our logical test. Now, we need to ask a question of the units column. So I say fSales arrow down to units tab. Anytime you are less than 15, that's one logical test, comma. The second logical test, fSales, and down to revenue discount. Anytime you are less than 20%, which is 0.2, that's the second logical test, close parentheses. If either one of those two logical tests comes out true, or will deliver a true to the logical test argument. Then if it comes out true, comma, what do we want to put for the particular transaction or record? In double quotes, we say retail. Now, isn't that cool? In double quotes, text is showing up as red. That doesn't happen over in Excel. Now, comma. Otherwise, or result if false, that means if both logical tests and or come out false, then we're going to categorize this as wholesale. End double quote, close parentheses. That is a calculated column. When I hit enter, that will be used as criteria in slicers, charts, and other visualization. You can't do that with a straight measure. You have to do it with a calculated column. All right, now we have two measures to create. I need total cost of goods sold and total gross profit. So I'm going to go up to New Measure. There's the measure, total cost of goods sold, equal sign, and then sum, open parentheses, and I need to get this cost of goods sold column, fSales. Down arrow, there's my cost of goods sold tab, close parentheses. And I definitely want to add some number formatting because this is something that will be dropped into visualizations. I'm going to say currency 0. Another new measure. This one's going to be called total gross profit, equal sign, and then sum, fSales, down to gross profit, tab. That's that column right there. Close parentheses, and we definitely want some formatting. English United States, 2 decimals. Now, if we look down over here, we can see our icons for calculated column, gross profit, net revenue, retail, wholesale, and then our icon for, uh-oh, there's a measure there. That is not supposed to be there. Luckily, we can right-click delete. But our measures are down here, total cost of goods sold, total gross profit, total revenue. Now, all of these 1, 2, 3 measures, we have the choice between calculated column and sum, which is what we did here, or a straight measure. Now we want to see an example of a measure that can only be created through a measure. Now, we calculated individual gross profit for each transaction and then total gross profit. If we want to calculate a measure for gross profit percentage that we can drag and drop and then filter with conditions and criteria, we cannot add a calculated column for a ratio, copy it down, and then, for example, add it. It will give us the wrong answer. The only way we're going to get to that is by actually taking an already aggregated total revenue, total gross profit, and dividing it by an already aggregated total revenue. So this will be a measure that we have to calculate using a measure that's not reliant on a calculated column. Gross profit percentage, space, equal sign, space. And guess what? We're going to use already calculated measures in another measure. Now, the convention is to simply use a square bracket. And notice it's pretty smart over here in Power BI Desktop. When I type a square bracket like that, it only shows me the measures. So I want to down arrow to gross profit. Notice it's in purple. Our convention for using measures and measures, only square brackets. If this was a column in a table, we would use table name and then column name in square brackets. But there you go. Divided by square bracket, and now we get total revenue tab. And I definitely want to add some percentage number format and leave 2 decimals. Now that is a gross profit measure. We can see it down over here. that gross profit percentage will be able to be filtered by product or month or any other conditions or criteria. So definitely, some cases you have to do a measure. Some cases, like the criteria for filtering, we have to create a calculated column. Now we actually have two more measures. I want to calculate a new measure, and we want to calculate average gross profit. Space, equal sign, space, average. And I simply fSales and down arrow to my already calculated gross profit. And I definitely want to create some formatting, English United States, 0 decimals, and enter. Let's create one more new measure. This one's going to be called standard deviation gross profit, equal sign, STDEV, and we have population data. We have all of the data for the 2-year period. So we're using the P, not the S. FS, and we're going to arrow down to gross profit, tab, close parentheses, and I'm going to show this as English United States, 2 decimals. Now, what is standard deviation? This is not the video for that. You can search my excelisfun YouTube channel. I have extensive videos on what standard deviation is. Standard deviation, however, is it is a measure of variation for gross profit, and in particular, it tells you how reliable your mean is. Now, sometimes when comparing the mean and the standard deviation across many products like we're going to do, it's hard to do it if the means are very different. So there's another calculation we can make called coefficient of variation. And it's simply standard deviation divided by the average. So we're going to create our last measure here. And this is going to be called coefficient of variation, equal sign. And we've already calculated average and standard deviation gross profit. So square bracket. And there, down arrow is our standard deviation divided by square bracket. And there's our average gross profit. Really what this shows you, and in fact, anytime you do division, it tells you whatever the numerator is per 1 unit of the denominator. And for us, it'll always be amount of standard deviation, which is a measure for variation per $1 of average gross profit. I'm going to hit enter. That will turn out to be a messy decimal. So I'm going to come up to format, select decimal number. Maybe we'll do 3 decimals. We can always come back and change it. We could also format it as a percentage. I'm going to keep it as 3 decimals and enter. Wow, so now we've created a bunch of measures with the little calculator icons and our calculated columns. Now, one thing we want to do before we go over and start creating our visualizations is I'd like to go through each table and hide columns I don't need to see in report view. So I'm going to click on calendar table. And we're definitely not going to need month number. So I'm going to right click and say hide in report view. Now, I would like to show you that there's going to be a problem with this table, and we're going to fix it. I'm going to go over to report view and just drag from the calendar table month name. Just drag it over here. Look at that, alphabetical order. It's trying to be polite. So I'm going to delete it. For calendar tables and other types of tables, in fact, our categories for counting transactions will have trouble too. But we need to select this column, and we need to sort it. And guess what? We had to create this month number column. So we have numbers 1 to 12 to tell this column how to sort. So I'm going to select this column, go up to sort by column, and select the month column. Now if I were to go over to report view and drag month name, it sorts perfectly. Look at the top, delete. Now let's go to D category. We don't need to see ID category, so I can right click, hide in report view. Go over to D gross profit category. Now this one will have a problem. If I drag this into a table for a frequency distribution to count, it'll sort incorrectly. So I'm going to select it and make it sort by this properly sorted column. sort by column, lower limit. And we still have one more issue with this table, but we'll deal with that in just a moment. We go over to D, product. We do not need ID. I'm going to right-click Hide in Report View. Suggested retail price. And you know what? I do not know how to highlight multiple columns and do this over here. Standard cost we do not need in Report View. Right-click Hide in Report View. Neither do we need ID for company. Hide. ID category. Hide. And we're definitely going to need this one. Now, there's two things we need to do with this column. The first thing is I want to rename it because it's going to show up over there. So I'm going to double-click and get rid of the website address, delete, and just call this product picture. Not only that, but I actually want these web addresses to work and actually go out and get the pictures and display them in our report. So I'm going to select the column. And up in Properties, Data Category, I'm going to tell the data model to understand this as an image URL. By selecting this data category, the pictures will be displayed in our report. Over to D, Supplier. I don't need the ID column. Hide. I wish I knew how to highlight from email all the way to state and hide them, but I don't know how to do that. Right-click Hide, Report. Right-click Hide. Right-click Hide. That's the only one that will show up. And down to fSales. We do not need date. Right-click Hide. We don't need product ID. Hide. Units we might need. Revenue discount we do not. Hide. Net cost equivalent. Hide. Net revenue we do not need because we have our measure for total. Hide. Cost of goods sold, same thing. Hide. Gross profit, same thing. Hide. We definitely need retail wholesale. Now that we've hidden all these columns, let's go look in Report View. And if we look over here, wait a second. I still see the columns I want, but the ones I didn't want are grayed out. Look at that. It actually is not until you publish that they completely are not seen. But that is helpful. Now, I want to go back over here. We actually have one last important topic. We have this fact table. But, of course, if we wanted to count transactions in accordance with these categories from our gross profit category table, there's no relationship, so we can't do it. So we're going to go over to the fact table. And here's what we need to do to build a relationship. There's the gross profit column. And I'm going to scroll down and pick a number. There's gross profit of $584.84. If we have the ability to look that up and do approximate match lookup like we can in Excel with VLOOKUP, we could simply look that up, go over to our category table, and VLOOKUP would race down until it bumped into the first bigger one and jump back. And you can see our category here is broken. We'll have to fix that too. But that's the category we want to use in our report, and that's where we want to count that transaction. There's a few ways we can do this. And I actually have a video, Excel Magic Trick 1137, which actually shows you how to do it both in Excel and Power Pivot DAX. But in that case, we had uneven categories. Because the increment is the same for each one of these categories, namely $250, we can go over to our fSales. And in a calculated column, we can actually round each number to the nearest $250. Now, actually, we're not going to use round. We're not going to use mRound. We're not even going to use ceiling. We're going to round down each number to the nearest 250 using the floor function. So I'm going to go up to Modeling, Create New Measure. And this is going to be called Lower Limit, equal sign, and then floor. Now, what floor does, it's the same as Excel floor. It's going to take a number, and that is our gross profit column, fSales, arrow down to gross profit, comma, and then the significance, that's the number to round down to, is 250. Close parentheses and enter. Now, if we scroll down and look at a few values here, there's 280, 256, 256. Those are all 250. That means we have the correct lower limit for each row for each one of our gross profits. Now we need to go over to Relationship View. We have our lower limit column and our lower limit down here. We can simply click, drag, and it knows that's the many side because many transaction will have a lower limit of 250. But over here, there's exactly one 250 and one category. I'm going to Control S. Now, I want to go back over to Excel. I'm going to open the Excel file. And earlier, I amended the last formula here, and it auto-filled the whole column. So I'm actually going to edit this back to the way we had it in the first place. Gross profit is less than, close parentheses, and join it to upper limit. Now, when I hit Enter, it auto-fills all the way down. And now watch this. This is what I should have done earlier. Highlight that. Double quote, and watch what happens when I hit Enter. It auto-fills up, but I'm going to point to the little smart tag and say Stop automatically creating calculated column. By the way, that is something you cannot do with a DAX calculated column. You can have a different formula, but here we have it. Control S, close this. Back over in our GP category table, well, look at that. It didn't update, but no problem. Home, refresh. And there we have our correct categories. And that's it. We're finally finished with creating our data model. We had to use Power Query or our Get Data query, and we used various methods for importing data. We then created a bunch of relationships, and we created many calculated columns and measures. We also hid a bunch of fields we didn't want to see, sorted the month name column by month, and sorted our category by the lower limit. We also did a few other things, but boom, we have our data model. Now let's go over to Report View. And we want to build our visualization. Now the first thing is we would like to have a picture of the product, gross profit percentage, and our coefficient of correlation. And I'm going to use a table to do this. So I'm going to click on the table visualization over here. Now I'm going to go down to the product table, and I'm going to check product picture and product. We can see that starting to emerge over here. Now I'm going to come down to the fSales table and check down here total gross profit and our measure up here for gross profit percentage. And we want coefficient of variation. Now I'm going to expand this over here. And actually, I think I'm going to indicate that this is coefficient of variation for gross profit. So right-click, rename. And I'm going to expand this. And very carefully at the end with my I-beam, I'm going to say space, in parentheses, GP, and enter. Now I'm going to pull this down. This is already quite amazing. Pull this down a little bit. Now I want to create a bar chart. So I'm going to go over clustered bar. And what I want to see here is the actual product name. So products. And I want average and standard deviation for gross profit. So average, and down here, standard deviation. And then pull this one down, resize it. And now we're going to add some slicers. I'm going to click in the white and click slicer. And then check year. We can resize it. Click in the white, I want another slicer. And then way down at the bottom of the fSales, we want retail, wholesale. We can resize it. Click in the white. I'm going to click on the slicer. Under supplier, we want to check company. And there's our companies. We can resize it. And then I'm going to click down in the white, and I want another table where I'm going to create my frequency distribution. Now we go up to GP category, and I want the category. I'm going to check it. And guess what? We did not calculate A measure for counting transactions. No problem. Right in the middle of reporting, we can go up to modeling. Now, I want to make sure, I almost made that mistake. I want to select the table over here and then go up to modeling, new measure. Our measure will be called count transactions equal. And guess what? All we have to do is count the rows for our fact table, FS tab. Because this is a data model with relationships, and when we select a condition or criteria from one of the lookup or dimension tables, because that filters the fact table, that fact table becomes much smaller. And so all we have to do is count rows, close parentheses. And I'm definitely going to use a comma separator here and enter. We see our measure down here. Now I can check it, and it goes right in to our frequency distribution. Now I want to do a little formatting for each one of these. This is a table, so I select the table. That little icon right there means, hey, those are where you drop the fields. That is an icon that's supposed to mean format. You know, I looked at that icon for a long time before I figured out what it is. It's actually a paint roller. I wish it was like the paintbrush over in Excel. All right, table styles, I'm going to expand none. I'm going to say bold headers, and there we go. Now I'm going to select the chart, and look at that. Now formatting has regular charting elements. I'm going to say data labels on. So I'm going to check, and there's the numbers. I'm going to click on one of the slicers, and down under header, I'm going to select the font color white and the background black. Now, for this next one, I should have selected them both. I'm going to select both of these using the Control key, and now I can simply come over to header and select font color white and then black. What happened there? Not sure why that didn't work, but we're going to try this again. And here's our table. I'm going to select table style, bold headers. Now let's check this out. Retail and everything updates. I want to see just Colorado boomerangs. Look at that. There's just the Colorado boomerangs. Just the comparison for average and standard deviation. Now here's the Colorado boomerangs. Let's check to wholesale. If we were comparing standard deviations to our averages, we can see over here our coefficient of variation from 0.52 to 0.39. If we go to retail, much bigger variation in gross profit. I go over to wholesale. Everything is updating. That's pretty amazing. 2016, boom. Now, you can actually add multiple pages. I'm going to come down here, double-click page 1, and call this product analysis, and then enter. We can create a new page by clicking a plus. And there it is, a blank canvas. I want to go over and select bar chart clustered. Come down to fSales. Scroll down here. I want to see total revenue, cost of goods sold. Up here, I'm going to select products. Come over, expand this. Come over to the paintbrush. Data labels, I'm going to say turn them on. Lots of people don't like those busy numbers. Sometimes we accountants like to see lots of busy numbers. And then over here, slicer. Click on slicer. Year, and then another slicer, month. I'm going to select both slicers. Come over to formatting, headers, font color, white, something like purple here. Select 2016. Maybe move these over to the side. 2017, January, February. That is pretty amazing. Control S, double click down here, product by date, and enter. Now we want to talk about publishing. But first, let's just see if we can print this. I'm going to click the drop down, and I don't see any print. Apparently, you can't print over here in the desktop version. However, you can publish it, and it's Easy to publish, and if you don't have an account, you can click the link to get an account. I have an account already. And it will publish it online, and there's some interesting tools available. So I'm going to go ahead and click the Publish button. I'm going to save my changes first. Now, I've already saved it there, but so it'll replace it. And now it's offering me to open this, so I'm going to click Open. And this is what you'll see. Already have account. I can sign in. New to Power BI. You can sign up right there. I'm going to go ahead and sign in. And there it is. This is an online version. I can come over and get my filters to work. I can go over to the product analysis and select a different filter. I can click refresh up here. I can edit the report. And if I click edit the report, here's those same options. And if we go look over here, there are just the columns we want. The ones that were hidden are hidden over here in the published version. There's our fSales. Now I'm going to click on Reading View. And I want to look at the File button. There's Print. You got to be kidding me. Look at that, Publish to the Web, Export to Power Pivot. And I want to try this Publish to the Web. And look at that, embed in a public website. It'll give us the embed code or the ability to email. Create embed code, publish. And there's the code for the email, and there's the code for a website. Now I'm going to copy that and actually hit pause and go put this at a website. And now if you click on the link below the video and go to the Excel Magic Trick 1366 Files section, there's a page. When I click on it, that's the embed code. I can literally click on this, and it's actually working just like it did in our desktop. And notice there's one of two pages. I can go to the second page, and there's our second page. That is absolutely amazing. So that was a pretty epic video about Power BI Desktop and even publishing it to Power BI Online. We, of course, started out the video importing, creating our data model, and then saw how to create visualizations. All right, we'll see you next video.